In Lab 1.2, the purpose of this lab is to use geometric patterns and provide visual support for extending number sequences. The materials we'll be using for this lab are the color tiles. These are the color tiles. We're going to look for patterns. We're going to let the first position be a square. We'll let the second position be an L. The third position is also an L. Remember, I want you to do these with me, so I'm going slow so that you can create the same pattern that I'm showing. I want you to visualize what you think the fourth will look like and go ahead and make that. Alright, so at 2 is an L. And if I ask you what the fifth or the sixth would look like, you can visualize what that pattern would be. If I ask you how many are in the 10th position, how many squares are in the 10th position, then we have to look deeper into the pattern. One way that is nice is to make a table to organize the information with showing the position and the number of tiles. In the first position there was 1 tile. In the second position there were 3. In the third position there were 5. In the fourth position there were 7. So now, without having to make the fifth, you would be able, by looking at common differences, to determine what the total number of tiles would be in the 5th position. So there would be 9. In position 6, we know there would be 11. But if I ask you to skip and determine how many tiles there would be in position 10, instead of having to count 7, 8, 9, and then 10, we want to try to look at a pattern that we see between the position and the number of tiles. So what can I do to 1 to get 1, that I can do to 2 to get 3, that I can do to 3 to get 5, that I can do to 4 to get 7, and so on. So I see a pattern forming in that if I double the position and subtract 1, I get 1. If I double the position and subtract 1, I get 3. If I double the position and subtract 1, I get 5. So I see a pattern between the position and the tile, so that now if I ask how many tiles there would be in 10, I would double and subtract 1. So there would be 19. And if I ask you how many there would be in the 20th position or the 100th position, you would be able to easily tell me by looking at the pattern. So I would double 20, subtract 1, double 100, and subtract 1. Now, if I ask you for any position that you are given, how many tiles would you have? And you would know to double that and subtract 1. So this gives me my conjecture, my generalization about what is happening in the situation. I can use this generalization from now on in terms of predicting what would happen next. So if I ask you how many tiles are in the 50th position, you would know to take 2 times 50 minus 1, or there would be 99 tiles. Alright, let's do another pattern together. These are going to be H's. The first has a column of 3 on each side and 1 in the middle. The second will have a column of 5 on each side and 2 in the middle. So I can see now what's going to happen with the third. Three, 5. So I'm predicting that the third position would have 7, in the column, and 3 in the middle. Well, these are getting pretty big, so I sure don't want to have to make too many of these before I begin to look at the pattern that is formed. 3, 5, 7. I can predict that with the fourth pattern that this column would be 9, and notice that the center is the same as the position. So there are 2 in the second position, 3 in the third position. So in the fourth position, I would expect 4 to be in the center. For the fifth diagram, I would expect that the columns would both have 11 and the center would have 5. So now if I want to find how many total tiles that I have, I might want to break this down and look at the columns and the center separately. So I'm going to create my table of the position and the number of tiles, but this time with the number of tiles I'm going to divide that so that I have the columns, I have the middle, and then I have a total. So for the first position, I have 3 times 2, or 6 for the columns, and 1 in the middle, so there's 7 total. In the second, there are 5 in each column and 2 in the middle, so there are 12 total. In the third, there are 7 in each column, there are 3 in the middle, so there are 17 total. So now for the fourth, we already saw the pattern. But if I look at the total, I can see a pattern forming in the total in that there are 5 5 is the common difference. So I can go straight to the total number of tiles on the fifth by adding 5 to 22. and I now have 27. It would be easy now to predict what will happen for 6, because I would just add 5 onto 27. But what is going to happen when I want to skip up to 10 and then on up to 20 and on up to 100 to get the total tiles? I need to have something more than their common difference of 5. So I'm going back to look at the position compared to the column. I know that the center, or the middle, let's go back, C is column, M is middle. I know that the middle will be the same as the position. So at position 10, the middle will have 10. And position 20, the middle will have 20. And at position 100, the middle will have 100. But I need to look at what I can do to 1 to get 3, that I can do to 2 to get 5, 3 to get 7, 4 to get 9. And what I see is that I can double the position and add 1. 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 And then, because there are 2 columns, I will double that. And that will get me the total in both columns. So now if I use this theory for 5, I would double 5 and add 1. So that's 11 times 2, or 22. The middle would have 5, therefore the total is 27, as we thought it would be. So now when I look at 10, I'm going to double 10 and add 1, 21, double 21 for the 2 columns, and I get 42. So I double 10 and add 1. That's 21 on each column. For both columns, it would be 42. So the total squares would be 52. Now let's look at 20. I'm going to double 20 and add 1. Most of the time when you double 20, you get 40. So 40 plus 1 is 41. Then double 41, you get 82. So you add that to 20, and you get 102. So you have 100. You double it and add 1. And that gives you 402 when you double 201. Then you add that to the middle and you get 502. So now we're ready to make our generalization about any number. The middle will be the same as the number. So the nth position will have n in the middle. Then we will double n and add 1 and then double that, which when I simplify gives me, when I distribute, gives me 4n plus 2 added to n is 5n plus 2. So notice that our generalization of 5n, and notice our common difference of 5. So there is a relationship there between the common difference and the coefficient 5. When I added 4n to 1n, 4 plus 1 is 5. That's where that comes in. So now I could use this generalization if I ask you how many tiles are in the 200th position. You could use 5 times 200 plus 2. There would be 1002. Alright. The next pattern that we make is going to be the pattern of your assignment. We're going to be making squares, and the first square that we will make will be a 3 by 3 square with the center open. The second square we make is a 4 by 4 . And it's all open in the center. The third that we make is a 4 by 4. Alright, so you have the first is the 3 by 3, the second is the 4 by 4, and the third is the 5 by 5. Sorry. Okay, now, so you have a 3 by 3, a 4 by 4, and a 5 by 5. So this is what the shape looks like for the pattern that you are answering the questions about on Blackboard. On Lab 1.2 on Blackboard, you have some questions about this pattern. Good luck.